Hi everyone, today we're going to be talking about systems of linear equations and their solutions. So it's just what it looks like. It's linear, they're straight lines. Now to find a solution, it's where the two lines intersect or where they cross each other. So today we're going to be looking at graphs. So the first thing we have to decide is whether the y is by itself or not, because we want it in slope-intercept form. So in this case, it's already done it for us. So we just need to start graphing our points. So looking at our first equation, our y-intercept is -3, so that's where we're going to put our first dot. Make sure you're doing this with me. And then our slope is -1, so we're going to go down 1 over 1, down 1 over 1. And you can continue doing this for a while, actually. You could do this forever, and we're not going to do it forever. But just enough so that we have a straight line. Okay, so if you have not done this already, go ahead and take a moment once again and draw this line out. Okay, so we have to draw our other line. Our y-intercept is 1. And our slope is 3, so we have to go up 3 over 1. Now, again, our solution is where they cross each other. So I could continue going up to the right all I want, but it's not going to help me. So instead, I'm going to go in the opposite direction. Since I went up 3 to the right one, I'm going to go down 3 to the left one. And oh, look at that, they cross. So we already know what the solution is for this equation. I'm going to continue drawing the line, though. So even if you see it, make sure you're drawing the line anyway. So our solution to this problem, where it crosses, is -1, -2. Okay, so that one was pretty straightforward. Well, this next one. So once again, we're going to graph these two equations. If you weren't done graphing the last two, make sure that you go back, pause the video, and then resume the video again. So we're going to look at the first equation. Our first dot is at 3 because that's our y-intercept. Our slope is 4, so up 4 over 1. Okay. Again, we can go backwards if we want to, down 4. And to the left 1. Oops, that's not what I meant to do. I meant to go for a line. Did I mess that up? 1, 2, 3, 4. Nope, we're still good. Okay, so you want to connect those dots. And now we're going to graph our other equation. So our y-intercept is at -2. And again, we're going to go up 4 over 1. That's our slope. 1, 2, 3, 4. Now, if you notice, they're actually parallel to each other. And you might have seen that beforehand with the slope. If they have the same slope, they are parallel. Well, what that tells us, I'm going to draw that line really fast, even though this doesn't look parallel. I'll have to fix that. What that tells us is they're never going to meet, which means there is no solution. So if you have a problem like this, you would just write in there, no solution. Oops. And that should be an N, or a U, I mean. There you go. So if it has the same slope, no solution, unless, and there's one other case, if it has the same slope. So again, if you're not done writing that down, pause video and then resume it again. So we're going to look at the third case. We have to get y by itself. So this first equation, that's pretty easy. We just have to add 3 to both sides. So y is going to equal 5x plus 3. Now over here, it's actually not that big of a change either. Since 2 is multiplying to y, we just then have to divide by 2 to get y by itself. So 10x divided by 2, we have 5x. 6 divided by 2, we have 3. Now, notice that we have the exact same equation. So we don't have to draw it twice, we just have to draw it once, because otherwise we'd be drawing the same line over again. So our y-intercept is 3, up 3. And then we're going to go up 5 over 1. And again, we could go backwards if we want to. Down 5, to the left 1, connect them. So once again, we're going to have two lines exactly on top of itself, of each other. And what this means is that there will be an infinite number of solutions, because if one line is on top of the other line, it's crossing or intersecting at every single point on that line. So there's an infinite number of solutions for this problem or system of equations. So the last thing that, once again, make sure that you go back and draw that all down and make notes to yourself. But this is the general idea. A system of linear equations, you can either have one solution where they cross at one point, 0 where they have parallel lines, or an infinite many solutions. Now remember when I said there was an exception to when they're parallel, when they have the same slope. See here, they don't have solutions. In this problem or this example, they have parallel slopes, but it's exact same line, so there's an infinite number. So hopefully that makes sense. If it doesn't, please ask your teacher. We're more than willing to explain that in a different way. But again, write down all of these notes, and we'll see you tomorrow.